Depreciation theory. This theory has a different approach to Einstein relativity. We start from Einstein's observation. Arrows shot from a moving train A and from a stationary location B will arrive at a target at a different velocity because of the motion of the train. However, such common sense addition of velocity does not apply to light. For explaining of this observation, we have this formula. Einstein went for time and he said passing of the time for any particle has a speed is slower, but we are going to distance. We say if there is a force on any particle, the size of the particle reduces. Einstein said passing of the time for the train is slower, but we say the size of the train reduces. Now we are going to second law of Newton. According of this law, if there is a force on any particle has an acceleration. The amount of the acceleration depends to the mass of the particle. More mass, less acceleration. Less mass, more acceleration. Now we are going to the atom. As you see, the heavy particles are at the nucleon and the light particles are turning around of the nucleon. If there is a force on the atom, according of the second law of the Newton, the different particle has a different acceleration and the nucleon won't be at the center of the atom. The electron must come to the lower orbit. As a result, the size of the atom reduces, just like a black hole. Now we are going to black hole. There are big gravity force there, and the size of the particles reduce and reduce. Passing of the time will be slower and slower. Finally, the electrons attach to the protons. The size of the particles going to be zero. Time stops. And now we have an example. We have a two car, both of them Toyota Corolla 1999. The first car has a 20,000 kilometer mileage on it, and second car has a 200,000. The second car looks older than first car. We can say the first car has a less depreciation, or we can say the passing of the time for the first car was slower. Can we say the amount of depreciation is equal with speed of passing of the time? Depreciation theory. According of this theory, the force is the reason for acceleration. Acceleration reduce the size. Reduce the size, reduce the radius of atoms. Reduce the distance that the electron turning around of the nucleon. This distance is like a mileage of the car. Less mileage, less depreciation, or slowing passing the time. As you see, slowing passing the time is equal with depreciation. I think the time is some things that we define that and we cannot consider is slower or faster. I think this is depreciation, not speed of the time. And finally, we have a question. If the relativity is not right, how it can help GPS to determine the location? The answer is we use atomic clock. This clock works according of radius of atoms, and this radius changes if there is force and acceleration. In fact, the relativity is just a correction of atomic clock.